Hey guys, how's it going? Today I want to show you guys a practical example of utilizing OpenVSP to measure the mass properties of an airplane. Uh, so today's example is going to look at the Cessna 172. Now, to save me a bit of work, I downloaded this model from the VSP Hangar. I'll give credit to this model designer here. You can go ahead and download that file at this link, and I'll drop it in the description below. The units of this model are in meters, so we'll be working with SI units today. So that means kilograms and meters uh, everywhere. So we can see, take a look at this model. Everything looks pretty clean in terms of the wing, the empennage, and the fuselage, and even the landing gears have some resolution to it. And in today's example, I'm not so much interested in accuracy, but more just trying to show you guys the steps. So I'm not going to fiddle around with the model too much. The only things I really want to add to this model are going to be a pilot, a passenger, fuel tanks, and an engine. Okay, so let's get started. So first off, I want to do a pilot. Uh, in VSP 330, there's now this cool new component called human, and it's very anthropomorphic. You can see a lot of detail, and I really appreciate it and what they've done with this. So the first thing I want to set is going to be the density. The density of the human is going to be pretty close to the weight of water, which is 1,000 kilograms per meter cubed. So we'll set that density, and that'll be used in the mass properties calculation later. For the length unit, I'm going to set them in meters. So that's going to be a pretty standard human height. And then I want to set the pose to sitting. So again, they've done some pretty cool updates on this human model, as you can see. I'm going to shift this guy a little bit off to the right here, maybe about there, maybe a little bit more. Yeah. So again, not too interested in accuracy, more so interested in uh, overall approximate numbers. So there's that guy. I'm going to actually mirror him across the XZ axis, and now we have a passenger. Let's give him a little bit more space, but again, not too interested in the details. Okay, great. So now I want to add an approximate engine block, and this engine block is going to have a different density than the rest of the fuselage. Okay, so here we go. I'm going to scale it down a little bit, maybe to about 1 meter by 1 meter by half a meter. We'll see if that fits in our engine nacelle. Still a little bit wide, so we'll shrink that down a little bit more. Great. So that is approximately our engine installation. Maybe just make it a little bit taller here and scoot it down a bit. Great. Again, not super interested in accuracy, just want to get the components generally there. All right. So now that we have this, I also want to set the density. I don't know what the density should be for my engine component yet, so I'll walk you through how to figure that out. Oh, and there's one more component I want to add actually. It's the propeller. I happen to know that a Cessna has a propeller diameter of about 2 meters, so that's what I'll set here. And they typically are 2 blades, so again, 2 blades there, and we'll scoot that forward to about the tip of the engine, about there. Okay, great. So now we've added some humans, we've added an engine, we've added a propeller. We now have a couple of different components here, and I think I want to add just one more component, but I'm going to make this just as a point mass. This point mass is what's called a blank geometry, and again, it's just represented by a single point in space. Let me see if I can slide it around so you can see it. Yep, there's just this point in space, and you can put that anywhere. And I want that to be my vehicle avionics and extra mass items. And you see under this mass properties tab, we'll be able to assign some mass to it. Okay, great. So now we've added that, we've added that. And now we can utilize OpenVSP to give us the volumes of each one of these components. That is done by clicking on the Analysis tab and going to Comp Geom. Here I've done a previous analysis, that's what you see here, but let me just re-execute it on this current vehicle. And now we can see we have volume and wetted areas for all components. Um, a lot of these aren't going to have wetted area values, and some will, but really what we're interested in is the theoretical volume. Now, before this video, I went and populated uh, various component weights from the Roskam textbook. I'm sure you guys are familiar with that. And by knowing the component volumes, I'm actually able to calculate a density to assign in OpenVSP. So for example, the fuselage has a volume of 5 meters cubed. So I can take that number, bring it over to my spreadsheet, and we now have an estimated density for that. As a quick check, we can see if our pilot plus passenger density comes out to pretty close to that of water. Um, so it's this value, 0.77. We can take that. We have to multiply by 2 because there's 2 passengers. And see, 1,000 kilograms per meter cubed. So there's a pretty quick way to get a density value for each of your components. So I'm going to go ahead and do this, and then I'll be right back. Okay, so great. I filled out my table, and you can see the volumes and the densities off to the right. Some of these are going to come out as pretty large numbers, but that's okay because what you're really interested in is capturing the total mass of the item. And if VSP is using this volume, well, then the total mass should come out okay, as long as you set the density appropriately. So we're going to go back to our model, and we're going to set the densities of each of these components. So if I check the density for the wing, it's going to be about 45 kilograms per meter cubed. The empennage components are going to do about 38, which is very similar to the wing, which makes sense. They should be about the same density. They are all lifting surfaces. The fuselage is going to be a little bit lighter at 33 kilograms per meter cubed. The struts and the landing gear, I combined it into one item here. So I'm going to set the density to this 536 number. Cool. So we'll see if this works out for us. As I said before, the pilot is going to have to be set to 1,000 kilograms per meter cubed, as well as the passenger next to him. Since they're mirrored objects, they'll each have that density. And then the engine block is pretty heavy. It's going to be up at 269. And the prop geom came out with a weird result, but I'm going to use it and see what happens. And then the avionics items, I know from here, like as I said, they're going to be a point mass, and I'm going to set those to 64. And again, I'm not being super accurate with any of this. I'm not even really double checking the numbers. I'm just going to kind of hope for the best in this video. But you should definitely take a lot more care in properly accounting for each of the mass items in your vehicle and their placement along the vehicle so that your CG, location, and mass moments of inertia come out correctly. Now, the other thing you have to do in OpenVSP is set the priority levels of each of the items so that when the total mass is calculated, VSP knows which items are inside and which ones are outside. And you should watch the OpenVSP tutorial videos more on this. But suffice to say that items that are inside other items will have a higher priority. So the humans in here have priority 1. The engine block has priority 1, and that's really it. So that when comp geom intersection occurs, OpenVSP will know what to do with those items. I forgot the fuel. Let me add the fuel to the wings real quick. Again, I'm going to represent them as point masses. I know the fuel tanks are in the wing somewhere about here. So I'm going to go ahead and copy that and do another fuel component. And this one will move to the other side on the negative side. Cool. And then we'll set their masses appropriately. So I have 144 kilos of fuel. So I'm going to do about 72 for each. Now I'm going to do the actual mass properties of this vehicle. So I'm going to go to Analysis, Mass Properties, and see what happens. Cool. So our total mass is up at 847, which is pretty close to the expected value of 885. So maybe I could tweak the densities to get a little bit closer, but we're pretty close on this first try attempt. I actually have another reference document which gives me the moments of inertia for this vehicle. Um, I just found these by Googling, but we can see that the moments of inertia should be about 1200, 1800, and 26 for X and Y and Z. And we see very close agreement with those numbers. So we've done a pretty good job of representing our vehicle. If I increase the number of slices here, VSP will even get probably even closer. So let's see if we can get a little bit closer. Takes just a little bit longer. But yeah, so now we have a slightly different mass. And so you'd probably want to do this kind of convergence study until you converge on a mass that works. And it even tells you where the CG of the vehicle is. So that red dot right there is where the CG is, which is really close to where it should be for the Cessna. If we see here, we see that the CG is right about in the cockpit, and that's exactly what's coming out here. So again, I could spend more time getting more accurate definition here, but I just wanted to show you guys really quickly how I would do this for this vehicle. All right, see you guys in the next video.